Okay, so I wanted to talk about what you brought up that the sun is the cause of global warming. And so you mentioned that scientists or that the people who are making these climate change models that they've forgotten that the sun or they haven't incorporated the sun into their models. Um, so I don't think that's accurate. One of the reasons I don't think that's accurate is because most of the models that we see that are saying like, hey, the Earth is warming by X degrees every year. We are seeing shrinkage in surface ice every single decade. That is all either reported by or corroborated by NASA, which is, while it's an American organization, they're very much an international organization. They really collaborate with climate monitoring organizations around the country and around the world. And so I think they're a very trusted resource when it comes to what's actually occurring on the planet. So one of the cycles you brought up, well, you brought up the Earth's, the sun cycles. Excuse me. And I do agree it does go through cycles. Um, there's two main types. There's the Milankovitch cycles, which is the geometric changes in the pattern, or the pattern that the Earth moves around the sun and how it changes geometrically. So there's three ways in which it does that. The first way is how it moves around the sun. If it's like a circle or an oval, I imagine there's a little bit of a 3D shift to that. But that's, I want to say it's called eccentricity. I never know how to pronounce that. But that's the shape of the Earth's orbit. And then there's also the angle that the Earth is riding on that orbit. So that's its obliquity. So you can kind of think of it like, is the North Pole pointing more towards or away from the sun? And then precession. So then, like, if your hand wrapped around the sun, like your fingers wrapped around the sun in the direction the Earth orbited, your thumb is pointing the direction that the Earth, that the orbit is pointing, if that makes sense. That's precession, and that changes as well. So those three things are the way that the Milankovitch cycles, they're summarized as the Milankovitch cycles. They have been monitored for a very long time, and because they are a geometric pattern, they modeled them backwards. So they mathematically regressed them, and they were able to figure out what the sun was doing in relation to the Earth and what the Earth was doing in relation to the sun for millions of years backwards. And they can figure out for millions of years forward about where the Earth will be in relation to the sun and what its movement will be. And the climate does not behave in a way that corresponds to the Milankovitch cycles. There are minor effects, like yes, the Earth will get closer or further away, and we will see like temperatures rise and fall respectively. But the actual like the trend of the climate does not match the trend of the Milankovitch cycles. So that's this article explains what they are, and then this next article talks about why the Milankovitch cycles do not explain Earth's current warming. So I'm going to leave all these links in the description. I'd encourage you to check them out. But summarized, they're just saying like, yes, they do attribute some climate change, but they do not explain climate change that's occurred over the past 2.5 million years ago. And they cannot account for the current period of rapid warming that we've had since the Industrial Revolution, about 1850 to 1900, and particularly since the mid 20th century. They're very confident, them and just in general the scientific community are very confident that it's due to human activities, specifically the input of carbon dioxide into the atmosphere. Carbon dioxide is a very warming gas. It captures heat very well as a gas, and it essentially insulates the planet, which I'll talk about in a second. The other thing that the sun does, you said the surface is very complicated. It has its own weather. I think you said that. Is the solar cycle. The sun does, absolutely. I agree it has its own weather. That oscillates in pattern about every 11 years, meaning that over an 11-year cycle, the activity on the surface of the sun goes from very tumultuous, a lot of sunspots and solar radiation emitted, to not as much. In that time, also the magnetic field of the sun flips, and then it continues on that cycle. And the thing to note there is that if it's an 11-year cycle, that does not account for the now decades of warmth. If it was a cycle it was going through that was just, oh, the sun's just, warming up, emitting more radiation, that's why we're warming up, then that would explain why for decades now we've been seeing this. And to make it more convenient, NASA actually averaged it out over 11 years what the Earth has been doing. And that's what is in this next slide. So they take an 11-year average to correspond to the 11 years of the solar cycle. And that's what this thick red line is. And that's what the thick red line is Earth, the thick yellow line is the sun. And so you can see the trend in temperature. Over here is the Earth's axis, so starting at 0 degrees Celsius change. We've had, since the 1950s, we've had a full degree of warming, but the sun has had total solar radiance, so watts per square meter, they have had a decrease. And so if the sun was getting warmer over that entire trend line, like here it was, then I would be like, yeah, absolutely, the sun is causing it. But the sun, since the 1950s, which is where we've seen this rapid rise, the average temperature of the sun has been going down, the average temperature of the Earth has been going up. So if the sun was really causing climate change, we would be seeing cooling. But we're not. We are not seeing cooling. I think I've forgotten to bring that tab up here. How do I'll just get rid of this one. On the explore page for NASA, Earth and climate change. Since the pre-industrial period, we've gone up a degree and a half. And since 1980s, we have lost over 10% of our Arctic sea ice, which has a whole lot of effects. But the thing that I want to really just kind of drive down here is that I think it is in this article. I'll look for it in a second. But in the Earth's atmosphere, we are seeing, hopefully you're still with me, I just had a weird pop-up. In the Earth's atmosphere, we are seeing the inside atmosphere, like the lower atmosphere, the stuff closer to us, that's getting warmer. And the outside layer, the external atmosphere, the stuff that's closer to space, that's getting bombarded with solar radiation first, that will go through a warming effect first if caused by the sun, that is getting cooler. And so it's kind of like the call is coming from inside the house. If the sun was warming us, we would see the outside atmosphere get warm sooner and then the inside atmosphere, but it's not happening in that order. So I can't say it's the sun. It's something happening inside the atmosphere. And what is happening inside the atmosphere is we are getting rapid rises in CO2 because of the emission of burning fossil fuels. And we are getting rapid rises in methane. Methane is its own problem because while it is more short-lived than CO2, it stays in the atmosphere for less. The capacity it has to capture heat is like 50 times as bad as CO2, which is more of a tangent. But anyways, those two activities, that's what's causing global warming, is that we are not able to dispel heat because of how much CO2 and methane is in the atmosphere. So it holds it in, and so then as we generate more heat, it just doesn't have anywhere to go. It would normally be irradiated back into space and absorbed by the oceans and stuff like that, but we are overpowering those cooling methods. And not only overpowering cooling methods, we have overtaken the sun. The sun would have let us cool down, but not only are we not like staying neutral, we have done what the sun, we have gone past what the sun would do and then some. That's how bad we are polluting, and that's how much we are responsible for this. I think it does say it in this article. Okay, they say a second smoking gun is if the sun was responsible for global warming, we would see warming throughout all layers of the atmosphere, from the surface to the stratosphere. But what we actually see is warming at the surface and cooling in the stratosphere. Which, again, we would see the stratosphere getting warmer. So anyway, I'll put all these in the video biography, all these links. Please check them out. Okay, bye.